This is the report on Better Sports Through Analytics, Improving the Safety and Training of UNCG Athletes. This is my capstone project for fall 2016. The kinesiology department has gathered data on student athletes at UNCG over the past 3 years. The data was presented as an SPSS file. This file contained observations on over 300 students, and the data was de-identified to protect subject confidentiality. Each row contained physical measurements from each subject for each of the years that they participated. Only 48 of the students had measurements ranging over the entire 3 years of the study. Each row also contained records of all injuries before and after starting the study. This project was a proof of concept on the usefulness of statistical software in analyzing the gathered data. The tools to be used for this project were Excel, SAS Enterprise Miner, and Tableau. Excel was used to edit and clean up the data, put it into a format that was more readily usable by the other tools. SAS Enterprise Miner was used to explore data relationships, cluster the data, and perform predictive analytics. Decision trees were preferred for this use due to their ability to learn despite missing data. Tableau is a powerful tool that can provide a wide variety of visualizations and interactive dashboards. The cleanup of the Excel data after it was exported from SPSS took 3 primary phases. The initial cleanup of the data was to cluster the columns into groupings by year and by injury, the first step in developing a normalized database. Note the names of the various tabs that were created along the bottom of the image from the file. Formulas were used in the injury data to help provide the injury flags that were used as targets for analytics. A new tab was created to consolidate all measures for each of the years into one single data source, picking the earliest measure for each subject. Setting up the injury flags was a 2-step process. The first, on the injury tab, search criteria were created combining subject number, injury flag, and body part or injury type values. On the demographics tab, using the vertical lookup function, we were able to set up flags according to subject and the presence of the type of injury that was being searched for. Exploration of dimensions in SAS Enterprise Miner was initially tried using all measures in a year against a simple injury flag. Later, focus was changed to studying knee or hip injury measures related to knee or hip injury flags. The clustering effort took place surrounding 4 groups of measurement columns: knee, ankle, hip, and head measurements. The clustering ideally needs to drop empty values, and several of the early runs dropped too much data, with 2 of the runs actually dropping all of the data. This led to the effort to consolidate measures to cut down on empty values. One of the clustering profile results is shown, giving displays of the difference between the population of the entire file versus the population of a population distribution of the clusters of a run. Decision trees operate on learning based on random splitting of the input file. All the decision tree runs split the input file into 60% for training and 40% for validation, which translates to 180 training rows versus 120 validation rows. Because the research shows that joint laxity and stiffness can be too high or too low, and that an optimal value of these measures would be ideal for avoiding injuries, a tree was created allowing for a maximum of 3 branches. The results are shown here. The resulting tree shows initial estimates for some of the measures that can avoid injuries. And moving on to Tableau, this software is extremely versatile in that it can connect directly to Excel or to a database. The connection details are kept separate from the report tabs, meaning that the change from using Excel as input to a future database could be done with minimal problems. The display here shows the tabs that were used from the Excel spreadsheet set up to join according to subject number as the foreign key between the tabs. The demographics was the starting point of the queries. They were joined by an inner join to the consolidated measurements tab. The injuries tab, which was consolidated into one single tab, was then used with a left outer join to ensure that measurements from all subjects were still available in spite of the fact that some of them did not have injuries. Displayed are 2 sample graphs that were created to show the potential of Tableau software. The first is a display of injury type by body part. The second display shows body part injuries by sport, colored for each class designation. A set of recommendations was made to the research team to facilitate the improvement of the research data gathering going forward after the completion of this project. The first was to create a relational database that is normalized and has a few improvements on the methods of gathering data that were used so far in this study. The diagram shown is a high-level concept drawing showing the decoupling of study subjects and their demographic information from the sports that they participate in, allowing for the recording of many-to-many relationships if those become necessary in the future. The storage of injury data will be in an independent table which would have unlimited utility. Measurements would be stored also in a separate table so that information could be recorded as needed, whether it's once a year or more often. A companion recommendation was verbally presented for a data entry and maintenance application for researchers to enter and update data as needed. Such an application could be created that is multi-platform and easily used in mobile devices. Once the database and the application are created and populated, the analysis and reporting of the data becomes far easier, making SAS and Tableau usage much more powerful than it can be at present. As we have seen, the raw data for the study was retained at all times unchanged from the SPSS file that was presented initially. New information was gleaned via the simple manipulations that were added to enhance the performance of the analytic software. The new tools of SAS Enterprise Miner and Tableau were shown to be useful in developing new information for the injury study, and proposals for future development were given and should enhance the usability of this data going forward. Thank you.